The object of the game with OLFAC is to develop a mathematical description of the camera and the laser and the way they've been physically put together when the module was built. Okay, so the way we do this is after they've mounted the camera in its box and they've assembled this whole thing, then we set it up in this OLFAC machine where we aim the camera at a target, and the target has got a pattern of holes on it that we know where they are, and the OLFAC software guides the user through the procedure of aiming the camera at the correct place on the target, aiming the laser at the correct place on the target, and then actually developing the calibration matrices which mathematically describe the camera and the laser and the relationship between the two of them. This data is attached. It's actually this reference, the coordinate system that we use on the cal target, okay, in the OLFAC machine, is the actual Cartesian coordinate system which gets handed. The calibration is done in terms of this coordinate system. Then later on, when it's used in Gaging, they figure out the relationship between this system here and the various coordinate systems that are being used in the car and in the ONFAC procedure.
Like, when you say you know where those targets are, you know where they are relative to what, where the camera and laser are mounted?
No, we know the target. I just sketched quickly. The target, the picture you see, looks something like this.
The relationship between the features on the
Just relative to each other?
Yeah.
Yeah, relative to each other. And there's some point on here which is 0, basically. I mean, if we say, and this is arbitrary. If this is 0, 0, then that basically what that means is that the OLFAC, when we get done with OLFAC, there is a coordinate system out there somewhere, which it's Cartesian. It's in linear units. The axes are perpendicular and so on, and then this coordinate system will be used later on in the other procedures. The only thing that's important at this point is that it's a real Cartesian coordinate system of some kind.
So head is just a list of numbers that enables you to make the measurement. Okay, if you could get the head by purely mystical means, okay, you would do so. There's no doubt about that. Okay, as it turns out, unfortunately, in practical life, you have to go to a lot of trouble to get it. Okay, the function that produces the head, the numbers that are in the head, is called collapser. It's been mentioned before, and collapser takes 3 inputs. Okay, these 3 inputs are labeled CAD data, target location, and ONFAC. Okay, now, what are these 3 things? Okay, I'm trying to think. Let's do an actual example. Okay, let's do the actual example of I wish to measure using a camera, okay, and a camera module with a little ray gun that shoots a beam of laser light down. I wish to measure exactly where the edge of this table is. Okay. Now the camera is over here. Okay. And I actually want. I don't want to know. What do I exactly want? I want to get the same measurement as if I had a little gauge come out, a little, what do they call, a little feeler gauge come out and push against here and measure just where the edge of this table is, okay? Camera's over here. The part gets presented to me. Now, one of the things, the way the part can vary is it can go up and down, it can bob up and down, okay? And it can also be, you know, in and out, and I want to see what would happen. In other words, you want to imitate as closely as possible. You want to get the same result that they would get. Okay, so, all right. So there are some numbers that do this. Okay, there are some numbers that if you tell me pixel image of a little dot of light on the thing, since that moves in the pixel buffer, there's some numbers that take you from that pixel coordinates to how far up and down it bobs. Okay? Now, when it bobs up and down, if the camera is here, also the image of the edge will also go up and down in the pixel buffer. Okay, so you have to take out the effect of the thing going up and down on the image of the edge. You can do that because you know how far up and down it's gone, okay? And then what's left over will be how far in and out. And there's some numbers that enable you to do this. Details are important.